Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz bin Yaakub. I am from Group 6. So today I want to present about my project about the project ceramic. Okay, we go to the next slide. Okay, my part is introduction. So for the mixture of the ceramic, we use three components of material. The first one is bauxite. We know that bauxite is an absorbent aluminum cyclosilicate clay consists mostly of monomer. The second one, the different types of bentonite are each named after the respective dominant element such as potassium, sodium, calcium, and aluminum. Expert debate number of nomenclatorial problem with the classification of bentonite clays. It is formed from the weathering of volcanic ash, most often in the presence of water. However, in the term of bentonite, as well as similar called crostine, has been used to describe clay beds of uncertain origin. The second material that we use is bentonite powder. Bentonite powder is a kaolinitic sedimentary clay consists of 20 to 80% kaolinite, 10 to 35% of mica, and 6 to 65% of quartz. So in the composition, they include the quantity of the major mineral, accessory mineral, and carbonaceous materials such as lignite. And they are in fine grain and plastic in nature. Unlike the most advanced clays, it is produced a fine quality white color pottery body when the material is fired. So the ball clay are relatively safe deposit due to the combination of geological factors needed for their formation and their preservation. It is commonly used in the construction of many ceramic articles, where the primary role is, apart from the color, is white, and either is the plasticity or to add logical stability in the shaping process. So the last material that we use is kaolin. So kaolin, we know that it is a kaolinite in clay mineral. It is part of the group of industrial minerals, and it is in the chemical composition SiOOH. So in this kaolin, it is in silicate mineral with one tetrahedral sheet of silica. It is the silica linked through the oxygen atom to the one of the hydral sheet of the alumina octahedra. So for example, rocks, we can see in our rocks that we can see it is enriched in kaolinite. It also known as China clay. So this kaolinite or the China clay has a low swell capacity, a low cation exchange capacity. It is very soft, earthy, and the color usually in white color. It also in the mineral form produced by the chemical weathering of aluminum silicate like feldspar. In many parts of the world, the color of this kaolin is in orange red because of the iron oxide, and it giving the distinct rust. So the concentration is lighter in mid white, yellow or light orange color. So for the commercial of the kaolin, they are mostly supplied and transferred as a dry powder and semi-granular or as leakage slurry. So that's all from me. Thank you.
Assalamualaikum. My name is Muhammad Hariz bin Kamal. My matric number is CD150112. I will explain about the procedures of this project. Okay. The wetting and mixing process is, first, the percentage of powder that we use is 20% of bentonite, 50% of clay, and 30% of kaolin. For total weight of powder that we use is 100 gram. If you can see, for the bentonite, 20 divided by 100 times 100 equal to 20 gram. For the ball clay, 50 over 100 times 100 equal to 50 gram for ball clay. And for the kaolin is 30 per 100 times with 100 equal to 30 gram. Okay. Next, mixture for one sample. For the weight required was 50 gram. The powder will be weighted using weight balance. The powder is then sieved and then mixed with the bentonite, bauxite and kaolin. Next, for pressing process. Firstly, make sure the mold is clean and remove the entire unnecessary object or any contaminant to avoid failure for sample. Next, make one sample of bentonite, bauxite and kaolin with dimension. Insert the mixture into the mold. Compress the sample with the pressure of 9 metric ton for 1 minute. After that, the sample is taken out from the mold. Next, sintering process for sample is 2 hours at 1300 degrees Celsius and cooling for 24 hours. For the testing process, the strength sample will be tested by using flexural strength with 3-point bending strength. And lastly, determine the bulk density of the sample with plane measurement. That's all from me. Thank
My name
you.
is Liyana Amirah binti Muhammad Kamil. So now I will explain on the result that we obtained from the experiment. So this is the result flexural test for specimen 1. We can see here from the graph it shows that the structure of specimen 1 at the beginning has a good condition, but after a few minutes of flexural test, the specimen structure shows there is a crack occur. For the specimen 2, there is no any crack occur during the flexural test. So this is the result for bulk density.
The discussion part, in this experiment, it can be explained that a few errors may occur from this experiment. One of them is friction. The friction effect at the load and support points will be minimized with respect to large deflection. This also implies that there will be no effect from friction on the contact tangency shift. However, friction will cause a moment acting out of the plane of the beam that cannot be ignored. When determining the bend strength by simple beam theory, it is usual to assume that the supports and the load points are frictionless, whereas in fact they are not. The presence of friction in flexure tests with fixed load and support points give rise to couples at such location as well as axial force at the neutral axis of the beam. The net axial force is relatively small and therefore is ignored here. However, if the moment is not corrected to account for the couple in the determination of flexure stress, an error will result. Next, the flexure strength of each brittle material is not only sensitive to the final surface finish because the maximum tensile stress occur at the beam surface. It is also highly sensitive to prior finish history. For this reason, it is impossible to specify an optimum surface finish procedure for all brittle material, so that failure will be due to inherent flaws related to the material or material processing, rather than an imposed defect resulting from the finish process. Therefore, rather than attempt to dictate surface finish requirement, it is suggested that each set of reported test data should be accompanied by surface finish history or material process history, whichever is applicable. Last but not least, significant changes in span length can occur in 3-point loading system if contact radii of support and load points are large compared to beam depth. The shift in point of tangency is a function of the contact radii, specimen thickness, and the ratio of the modulus of elasticity to the bend strength. For material that behave elastically, such as considered here, the change in tangency point and thus The error arising because of the change in moment arm from the ideal can be predicted mathematically for linear system. Thank you.
My name is Siti Afifah binti Jaafar. Okay, for the conclusion, this experiment for ceramic project is done successfully. In this experiment, we have compiled 3 materials that we mentioned at introduction, which is bentonite powder, ball clay powder and choline powder. After that, in our procedure, we have done 3 process, which is wedging and mixing process, pressing process and testing. According to the result, the condition of structure for specimen 1 and 2 was good after sintering when doing the flexural strength test, but after a few minutes, the structure for specimen 1 show a crack while specimen 2 does not show any crack. We can see that the higher the break force, the stronger the structure. Then for bulk density, the result show that the temperature we get is 24.8 Celsius. Weight in air is 2649.7. For weight in liquid is 1462.5 and density is 2.2240 gram per centimeter cube. Last and but not least, we can say that the experiment was very challenging for us and give us a new lessons for the subject ceramic and polymer. That's all from us. Thank you and Assalamualaikum.